Good thing I did this one. So lesson 8, question 16. So the trick with this one, work is formula we have, and it is, if you're given it in terms of vectors, it's u dot v. So we need to find our force vector. So what it translates to is your force vector dot your displacement vector. So some people in here will be getting the wrong answer, and I just want to explain the why. So we know the direction of the force is 1, 1. All right, so our force vector is, it has to have a magnitude of 10 newtons. All right, but it also needs to have a direction. So right now, the direction would be 1, 1. Now, however, in order to come up with your force vector, we need to make sure the magnitude is 10. So the only thing we need from this is we need a direction. All right, so we don't need the magnitude of that vector, so really we need to find the unit vector to get our direction, because the magnitude will be 1. Okay, so what that means is that the unit vector, so if we're going to calculate force, it's going to be 10, and if I simply multiplied it by 1, 1, it will have the right direction, but the magnitude is not going to be 10 because this is not a unit vector. All right, not a unit vector. All right, so we can't use that. We need to find the unit vector. So I'm kind of making a mess here. So to find that unit vector, we know that I'm going to call it vector A for argument's sake, is 1, 1. The unit vector will be 1 over the magnitude. So that's just doing 1 squared plus 1 squared. So it'd be root 2, 1, 1. So that is the unit vector. So that has the right direction. So it has the direction. And it has a magnitude of 1. So now we take that vector and we put it into the force vector. So I have my direction, but I want a magnitude to be 10, so I'm going to take the unit vector, multiply it by 10, and we have 1 over root 2, 1, 1. So that means we'll have 10 over root 2, and the vector is 1, 1. So that is a force of 10 newtons in the direction we want. So that's a lot of explanation just as to the why for your force. So we can plug that back into the equation. Once you see that once, you know that you need to find the unit vector. You won't need my long, windy explanation. Dot, our direction vector. Well, the direction vector is just going to be PQ. So 10 over root 2, 1, 1. So again, that's a unit vector with a magnitude multiplier of 10. Vector PQ is just Q minus point P. So that would be a 7. 6 take away 1 is 5. Now I can do the dot product. Remember the properties of the dot product. I don't have to distribute that 10 root 2 in. I can do the dot product and multiply it in after. So the dot product here would be 7 plus 5. So that is 12. So I'd have a 120 over root 2 joules. Now you're probably looking at the answer and saying, no, that's not what the answer is. So we need to rationalize the denominator. Some of you might have heard of this in your grade 11 and 12 course. Some teachers, there's not as much emphasis on it, but if you are heading into especially a math program, computer science program, and engineering, they want you to know how to rationalize, and basically you can't have square roots in your denominator. So you're going to multiply top and bottom by square root of 2. So if people haven't seen this before, so that's just equal to 1. So you're not changing the value, all right? But what it does then, on top we have 120 multiplied by root 2. Denominator, root 2 times root 2 is just 2, which reduces to give us 60 root 2 joules. All right, and that's what the answer shows in the solutions. So therefore, the work would be 60 root 2 joules. So hopefully that makes sense and that clears up any trouble you had with this question.